ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Right, guys, let us continue with the concept. We were in the discussion about stamens or androecium arrangement. For the last class, we have done the block diagram. What are the categories like cohesion and adhesion? Now, in this class, let us discuss in detail each and every type along with the examples. Examples are very important. Make sure that you note down, try to understand what is the concept along with the examples. So, with what we are continuing our discussion here, arrangement of stamens or we call androecium. In this, the two categories, the first category itself is called as cohesion and other category itself is called as what? Adhesion. What is the first category? The first category itself is called as cohesion and second category itself is called as adhesion. Right. Now, what we studied for the class, cohesion meaning what? Cohesion is nothing but fusion of similar members. So, we study here fusion of similar members. Now, so this cohesion is further divided into three categories. Three categories we have. What is the first category in this? Let us study. The first category under this is Adelphi. What is the meaning of Adelphi? Adelphi, the meaning is nothing but fusion of filaments leaving anthers free, leaving anthers free. Okay, so here Adelphi condition meaning what? Fusion of filaments leaving anthers free. Now, when you take the fusion of filaments, what's the meaning of this? For example, in a flower, when you look at, this is a flower I am drawing. Now, in this case, if you look at, this is nothing but thalamus. Maybe this is one filament. This is first filament. This anther is free. Now, this filament, this is a filament stalk. That filament is fused with another filament like this. And here anther is free. And that is fused with the stalk of this filament, again fused with another filament, and the anther is free. And you can see some space between the anthers. They are not joined. Excuse me one second. They are not joined in this case. So, here you can see some space in this between anthers, you can see some space. So, when space is there, that is a clear indication that anthers are not fused. Anthers are not fused. What are fused here? Only filaments are fused. So, this is attached to another filament. It is joined and attached to other filament. Again, in this case, anther is free. Again, this is attached and joined with another filament and that is free. So, here what is the basic meaning of Adelphi here? Adelphi meaning here the fusion of filaments. Fusion of filaments means all filaments joined together leaving anthers free. So, here in this flower you can see these all are fused filaments. And here the anthers free. You can write here clearly are free anthers. So, in this case you can see free anthers and these all are nothing but fused filaments. So, the condition itself is called as Adelphi. I repeat again, Adelphi meaning fusion of filaments leaving anthers free. All filaments are fused. One filament is joined and attached with another filaments, but anthers are free. Anthers are not united Anthers are not joined together, anthers are totally free. Such type of condition, such type of arrangement of stamens is called as Adelphi, right. So, here let us talk about the types here, subtypes. So, Adelphi, it is further divided into 3 subtypes. 3 subtypes. Guys, when you make here, the cohesion is divided into how many categories? 3 categories. What is the first category here? Adelphi, first one. We will discuss later what is the second category? Syngenesis or Syngenetious. What is the third category? Synandros. You need to have a very clear clarity in your young mind here. When you take the cohesion is divided into 3 categories. What are they? First one is Adelphi, second one is Syngenetious, third one is Synandros. Where are we? We are in the discussion about Adelphi. What is Adelphi here? The fusion of filaments leaving anthers free. In this diagram you can see fused filament leaving anthers are free. Now this is again Adelphi is subdivided into 3 types. What are the 3 types? So here we can take an arrow mark from the Adelphi here. So in this again we are writing the categories. Under this let us take A. The first category under this is nothing but we call Adelphis. The first category we call it as what? Adelphis. What is a Adelphis meaning here? In this, filaments are joined, filaments are united into one bundle. Filaments are united into one bundle. I repeat again, Adelphis means no doubt filaments are joined, no doubt filaments are fused, filaments are united, all filaments are united and they united into one bundle. When you can see one bundle, then it is said to be Adelphis condition. So, for this I am drawing the diagram in this case. Now, if you look at in this case, let us say this is a flower diagram what we have. In this same diagram I am drawing, all joined together, all filaments are joined together and form one bundle. All are joints and forms only one bundle. But in this bundle, remember you find as usual free anther. Free anthers we find very clearly free anthers are there, all will join united and lead to formation of what is called as one bundle. When there is formation of one bundle with the fusion of all the anthers, with the filaments are united, then the condition is called as what? Adelphis. Right. So, Adelphis condition, let us take the example, try to remember, we find in case of hibiscus. Hibiscus rosa sinensis. Hibiscus rosa sinensis, it is commonly called as China rose. It is commonly called as China rose. I repeat again, Adelphis. Adelphis meaning filaments are united into one bundle. Example, we can take hibiscus rosa sinensis, commonly called as China rose. Right. Now, coming to this next one, Adelphis. What is the condition we write? A Adelphis. So, here the same definition I write, but into 2 bundles. All filaments are united or joined, fused into 2 bundles. How many bundles? 2 bundles. Again I repeat, Adelphis. Di means 2 bundles. All filaments are joined, united into 2 bundles. Now, such type of condition we find in case of, example I am writing here. Now, we say pea plant. Pea plant means Pisum sativum, scientific name, and beans. Beans, when you take, nothing but what? Dolichos lab. What you find here? Dolichos lab. Dolichos lab is a scientific name for beans, and Pisum sativum is a scientific name for pea plant. Now, in this case, what you find? Now, here then showing the diagram in this case, Adelphis condition. I am showing the diagram here. So, better I will draw the diagram here itself. Now, look at here, Adelphis condition I am drawing at this time, at this place. Look at here. Now, in this case, the flower is here like this. Now, all filaments are joined. For example, if you take Pisum and beans, I will try to give you one more important point that we will study later in other chapter, but try to remember I am giving you here itself. In case of pea and beans, we find the arrangement as 9+1 arrangement. This is very important. So, here 1, 2, 3, 4, 5, 6, 7, 8 and 9. In this, all filaments are joined, but leaving 9 anthers free, and there is only one stamen separate. This is 1. So, we call the arrangement as 9+1 arrangement, especially in case of pea plant and beans plant. Very important. That means, in some of the families, which family both will fall in? Fabaceae. For the last classes we studied, in the family Fabaceae, we find the plants called pea plant and beans plant. Very important point is, of course, we know that Adelphis condition means we will remember as filaments joined together and form 2 bundles, that we will remember, right. But what else is important to remember? If you look at, both plants belong to Fabaceae family. In Fabaceae family, if you look at the arrangement of stamens in pea plant and beans plant, they find 9+1 arrangement. 9+1 means 9 filaments are joined, leaving 9 anthers are free, and you find one stamen separate. So, this is called one bundle and this is called another bundle. Of course, other bundle has only one stamen, but still it is called one bundle. So, there are arrangement is 2 bundles. So, the condition is called as Adelphis. Very important. See, I kept 3 star marks. Most repeated question even in the final NEET exam. So, this question we just generally get repeated. Either we get this question directly from morphology, because we are in the discussion about morphology. Sometimes the question will be related to taxonomy. In taxonomy, we are going to study about the family called Fabaceae. At that time, we will discuss all the details about Fabaceae. At that time, once again we will study pea and beans will have a 9+1 arrangement that will come in the category called Adelphis. Right. Now, this is second category. And what is the third category? Polyadelphis. What is the third category we call? Polyadelphis. That I will write in continuation of this. Guys, this part is very important. I will repeat again. In arrangement of stamens, we are in the discussion about cohesion. Later, we will go for discussion of adhesion. That part will come later. Cohesion is nothing but fusion of similar members. Just quickly revise in your mind, try to concentrate. Examples are very easy to remember. Concept is also very important and easy. So, guys, try to concentrate and revise in your mind. So, cohesion is divided into 3 categories. One is Adelphi, look at the pronunciation, this is called Adelphi, and this is referred as Syngenesis, and the third condition as Synandros. Now, we are in the discussion about first one, that is Adelphi. What is the meaning of Adelphi? Fusion of filaments leaving anthers free. Now, in the diagram you can see all filaments are fused, but anthers are free. Then the condition is called Adelphi. Adelphi is further divided into 3 subtypes. Monadelphous, Diadelphous. Now when you take the Monadelphous, in this filaments are united into one bundle. All filaments, they are joined together, all filaments, and they are joined together and they form only one bundle with the fused filaments. When you see, it is called Mona, means one Delphus, means one bundle. Where do you find? Hibiscus rosa sinensis, China rose. Now coming to a Diadelphous condition, meaning here filaments are united into two bundles. Now we can see two bundles. Now for example, very importantly you have to remember this, I am repeating because this is very important. Pea plant, Pisum sativum is a scientific name, beans is scientific name is Dolichus labla. In both of them we find Diadelphous, meaning two bundles, but here the arrangement is 9 plus 1. That means 9 filaments are fused, leaving one stamen free. Even though this is one stamen only, but itself is called one bundle. 9 are in one bundle, one stamen is in one bundle, it is called Diadelphous. So sometimes numerical question comes, guys, at that time remember Pisum, and for beans you have to take the arrangement 9 plus 1. So what is the third one? We have to continue our discussion. Polyadelphis. Guys, better I will draw the diagram down, just look at. So if you take, this is the flower, all joined together and form this. So there are many bundles. So here there are many bundles like this, yes. Okay, so in this case you have to understand free anthers. And what you have to understand? Fused filaments. Why I am drawing again? Because let us have a comparison with the second category. So under Adelphi condition we discussed about 3: Monadelphous, Diadelphous, Polyadelphous. Now under cohesion, first one Adelphi is completed. Let us go to second one, Syngenesis. And what is the third category? Synandros. Now let us come to the Syngenesis. What is the meaning of Syngenesis? So far what we have understood in case of Adelphi, all filaments are fused but anthers are free. Now we make the condition as reverse, then it will become what is called Syngenesis. What is the meaning of Syngenesis? Now in this case we will write anthers are fused, leaving filaments free, What is the meaning of this? All anthers are joined together but filaments are free. That means quite reverse condition of this, which we call it as the condition called as what? Syngenesis. Right. Now let us look at this Syngenesis. If you look at, now again I am drawing the flower. Let us take, this is the flower condition. What do you find in this case? In this case, see now, all anthers are joined together, all anthers are fused. Let us make it somewhat big for your clarity. Here I will draw somewhat big anthers. Now let us take, this is the anthers. This all are fused, but filaments are free. Can you able to see this very clearly? What we study here, this anther is fused with this is fused with this is fused with this. That means here anthers are fused. So I write here fused anthers but free filaments. Filaments are not joined, not attached, they remain free. Anthers are fused but filaments are free. Right. Now such type of condition we find in case of what? Syngenesis. Syngenesis means we find the condition fused anthers but filaments are completely free. Now coming to Synandros. Now when you take the Synandros condition, now coming to Synandros condition here, now if you take quite reverse will make it. Now in this case fused filaments, anthers are free, it is called Adelphi. Reverse if you make, anthers are fused, filaments are free, that you find in case of Syngenesis. Now coming to Synandros, this Synandros if you look at, in this case both, I will write here, both anthers and filaments are fused, That means anthers are also fused, filaments are also fused, then the condition is called as Synandros. Now look at the diagram in case of Synandros. Now if you look at, so if you look at, this is the condition. Right. So here, this is how you look like this. So this is what the flower is. At a time when you see under microscope, you cannot make much of difference, because in this case the filaments are also fused, anthers are also fused. Maybe this is one bundle in which all filaments are fused, this also all filaments are fused, anthers are also fused, this is another one. So if you see internally, what will be the thing? Anthers are joined together, in this case filaments are also joined together. Filaments are fused, anthers are also fused, both are fused, then the condition is said to be as what? Synandros. Try to remember, anthers are fused, filaments are free means Syngenesis we call, both anthers and filaments are fused means we call Synandros, and here only filaments are fused, anthers are free, then the condition is called as Adelphi. I hope it is very clear now. Now we completed the part called cohesion. What's meaning of cohesion? Union of similar members. Similar members means what? One stamen fusing with other stamen, but the arrangement is different. In one of the case, filaments are fused, anthers are free. It is called Adelphi. In this monadelphous, diadelphous, polydelphous. We are in polydelphous, filaments are united into many bundles, where you find citrus and bombaxiba. Coming to Syngenesis, quite opposite. Anthers are fused, leaving filaments free. That is called Syngenesis. What is Synandros? Both anthers and filaments are fused. Anthers are also fused, filaments are also fused. The condition is said to be as what? Synandros. Now first part is completed, that is cohesion. So what is the second part we have? Adhesion. Let us continue with adhesion. What is the second time we have to continue? Adhesion. Right. So what we have to understand about adhesion is nothing but joining of dissimilar members. What we have to study here? It is nothing but union of, or we say fusion of dissimilar members. Fusion of dissimilar members. Now this is being divided into how many categories? This is again divided into 4 types. What are the 4 types? Let us take the first one. The first one is called as epicephalous. What is the first condition? Epicephalous. So guys, if you look at very clearly, epi means on the surface. Cephalous meaning what? Sepals. Epicephalous means on the surface of sepals. What is happening? Stamens are fused with sepals. This is a sepal, this is different. Stamen, this is different. Both are fused. So they are dissimilar. 2 different things are fused. So, what is sepalous here? Episepalous meaning we can write fusion of stamens with sepals. What are the two things are getting fused? Stamens are fused with sepals. Then the condition is called as what? Episepalous. Meaning here stamens are fused with calyx. Sepals meaning what? Calyx. Both are joined, both are attached. Then the condition is said to be as what? Episepalous. Let us take the example Graveolea or Graveola. Graveolea or Graveolea. This is commonly called as a silver oak. Scientifically it is called as Graveolea or Graveola. So commonly it is called as what? Silver oaks. Now similarly we have the next condition Epipetalous. What is the meaning of epipetalous? Then we say here fusion of members of family Solanaceae. Generally the condition we find in case of Solanaceae. Solanaceae is a family generally we find where stamens are fused with petals. So what are the two examples I mentioned here? Solanum, Datura, both of them belong to the family called Solanaceae. Then the condition is called as epipetalous. Then the next category Epiphyllous. What is the next category we have? Epiphyllous. Now in case of epiphyllous we just generally take fusion of stamens with perianth. What are the two things are getting fused here? Stamens are fused with perianth. Guys, if at all if you remember, perianth is nothing but what? When you take the perianth, this is perianth. What is the meaning of perianth? Calyx and corolla are not distinct. Not distinct. Meanings cannot be differentiated. Calyx and corolla are not distinct, meaning calyx and corolla look similar. You cannot differentiate into calyx and corolla. When both look similar, it is called as perianth. Now, in this case, what are the two things are getting fused? Stamens are fused with perianth. So, this you find in case of, for example, we can take asparagus and lilium. Right? Asparagus, lilium, even lily plant. You can take common name because lilium means you will not understand. Better you take the common name. Generally, perianth means you have to imagine lily flower. You know lily flower. Better you take common name lily flower. Right? In lily flower, calyx and corolla look white, same color. You cannot differentiate calyx is what, corolla is what. That is why we call perianth. Now, perianth is joined and fused with stamens and the condition is called as epiphyllous. Guys, if you observe clearly, these two these belong to the family Liliaceae. You know, in the table we are discussing three families, Fabaceae, Solanaceae, Liliaceae. Now, these two are the characteristic feature of which family? Liliaceae. That means, guys, when we go to next chapter, taxonomy, at that time most generally questions will come interrelated with morphology and taxonomy. At that time, there we study simply Epipetalous for Solanaceae. So, under Solanaceae family, in the next chapter called taxonomy, we simply write Epipetalous. What we will write? Solanaceae family, in that we will write Epipetalous. At that time, what you need to recollect in your young mind? You have to remember that stamens are fused with petals. Then the condition is said to be Epipetalous. Where do you find such condition? Solanaceae. Similarly, when we are discussing Liliaceae, at there we simply write the condition called epiphyllous. So, when we are talking in taxonomy about Liliaceae, simply when I write the word called epiphyllous, then you need to recollect it back. Oh, epiphyllous condition meaning stamens are fused with perianth. That is a characteristic feature which we find in case of Liliaceae. Now, next category, let us take the fourth category, D category. What is D category? Gynostegium. Gynostegium. So, let me write the gynostegium fourth one here. I am writing here once again a gynostegium. What is the meaning of gynostegium in this case? We say that stamens are fused with gynoecium. So, what we write here? Stamens are fused with gynoecium. Then they can call the condition as gynostegium. Gynostegium, gyne means gynoecium. Stamens are fused with gynoecium. Then the condition is called as gynostegium. Right? Such type of condition we find in case of, just here I am giving you example, we find in case of cucurbita. So, here example is cucurbita. Now, this is what we call it as adhesion. Again I repeat, adhesion meaning fusion of dissimilar members. It is of four types. Episepalous means fusion of stamens with sepals that find in case of Grevillea, silver oak is a common name. Epipetalous condition, petals fused on the, epi means on the surface. Petals fused on their surface with what? With the stamens. So, we say fusion of stamens with petals. Remember Solanum and Datura. Epipetalous condition most commonly observed in the family Solanaceae. Try to remember, this point is very important. Again we are going to discuss about this in the chapter called taxonomy, coming chapter. Next, epiphyllous meaning, try to remember, stamen, fusion of stamens with perianth. What is meaning perianth? For few previous classes I told you, perianth means you have to remember, calyx and corolla are not distinct, meaning both look similar, no difference between calyx and corolla. Then you call perianth. So, here stamens are fused with perianth here. Now, generally example asparagus and lily. Both of them belong to which family? Liliaceae. Liliaceae commonly we find epiphyllous. Next is what? Gynostegium. Stamens is fused with gynoecium, and find the case in case of cucurbita. Now this will come under what? Adhesion, fusion of dissimilar members. Cohesion meaning fusion of similar members. Now in the flower we have calyx, corolla, androecium and gynoecium. Now, androecium, arrangement of androecium we studied now. Let us continue with gynoecium. Gynoecium itself is also called as pistil, also called as carpels. Right? Now within the flower when you look at, we find the condition of gynoecium. Let us look at the structure. Structure of gynoecium. Generally when you take the bisexual flower, in that both androecium and gynoecium are present. When you take the pistillate flower or we say carpel flower, unisexual flower, then we find only gynoecium. Now if you look at in the gynoecium structure, we find long structure like this. Right. Now this is called stigma. Stigma is nothing but upper one, you find some infoldings or invaginations are present, it is called as stigma. Stigma is also called as receiver of pollen grains. What is the meaning of pollen grain? What is a PG? PG meaning pollen grain, means it receives the pollen grain. So from anther whatever is coming, for example if you take, this is the anther of another flower. When you take, this is the anther, what comes out here, it is nothing but pollen grain. Pollen grain come and fall on the surface of stigma. Pollen grain will come and fall on the surface of stigma. This is called stamen. Let us take. From the stamen, the pollen grain comes out and falls on the surface of stigma. That is why stigma is also called as what? Receiver of pollen grain. It receives the pollen grain, or this is also called as landing platform pollen grain. It also acts as landing platform, means on which this acts as a platform on which pollen grain will come and drops or it will fall. So, this is also act as landing platform for pollen grain. Now, this is supported by long stalk is there. The long stalk, long tubular structure itself we call it as style. Style is nothing but what? A long tubular structure. So, this is nothing but what? Long tubular structure. Now, this is itself is called as what? Style. Then at the base what we find, it's called ovary. This is what is called ovary. Now, at the base of the ovary, here in the center of the ovary, we find the tissue which supply nutrients to the ovary. Now, this is what is called placenta. This is what itself is called placenta. Now, at the base of the gynoecium, we find the ovary is there. Within the ovary, in the centermost tissue will be there. This tissue is nutritious, which supply nutrients on either side to the ovules. So, on either side what you find in this case? On either side we find ovules. On either side what you find? On either side we find what are called as ovules. Right. So, here what is the arrangement here we find? Now, in this case structure of gynoecium when you look at, this is called stigma, also called receiver of pollen grain, or it acts as landing platform for pollen grain because pollen grain will come and fall on the surface of stigma. Now, this is supported by long tubular structure is called as what? Style. At the base of the style we find the structure called as ovary. Now, within the ovary centermost structure tissue which we call placenta. Placenta will supply nutrients on either side to the arrangement of ovules. Now, you can see these are called ovules. Placenta will supply nutrients to ovules. Right. So, this is what is called gynoecium. So, gynoecium is immediately you have to remember stigma, style and ovary.